Okay, so now let's test for reliability, right? So the first step was to test to um, operationalize your variables, and there we had to kind of establish how we're going to measure those variables. For step two, we want to test for reliability, right? And with reliability, it comes down to this idea of consistency. And reliability is the extent to which a measure is consistent and stable. In other words, people respond similarly to that particular measure each time, right? Now, anxiety is not the best variable to use when you're talking about reliability because I might be anxious right now and not anxious later. But let's imagine anxiety was a stable construct. It was something that doesn't really fluctuate uh, within a person very often. So that means if I measure the anxiety today and whatever score I get tomorrow, if I measured it again, I should be getting similar responses for your anxiety today and yesterday. Now, again, anxiety is not the best measure here to look at because anxiety does fluctuate. But again, imagine we had a construct that doesn't fluctuate. So let's say your attitudes towards gun control. And if I asked you, if I measured your attitude towards gun control today, and then I measured it a week later, if my measure is reliable, I should get similar results from your responses today as I would a week from today. If they vary drastically, where like today you're on the 1 to 7 scale, you're at a 7, and then next week you're at a 2, that would indicate that my measure is not very reliable. I should be getting either sevens both times or twos both times or something around that range, not ones that are very drastically different from each other. So again, reliability really gets at consistency. So to give you another example, imagine you had to catch the bus to school and it's the 8:30 bus, right? And here are three scenarios. Look at them really quickly and figure out which scenario do you think the bus is more reliable. So if you look carefully, scenario three, there's only really a 1 minute gap, either a 1 minute early or 1 minute late after 8:30. So that's going to be your scenario in which the bus is most reliable. The other two outcomes, like if you get to the bus at 8:30 in scenario two, on Tuesday you would have missed the bus by 15 minutes, right? So as you can see, there's a lot more variability in scenario two than scenario three. So as you can see, scenario three is a much more reliable bus because you get relatively similar times the bus arrives each time. Same idea with a measure. You want to have a measure in which you get similar responses from the same people each time. Now, when we're talking about reliability, we need to think about our observed score. And our observed score is our true score, so what people really think, plus an amount of measurement error. Now, the true score is what people actually think, feel, or behave. Um, Measurement error is any fluctuation away from that true score, right? And it could be due to things like awkwardly worded questions, or people not feeling comfortable being honest, or maybe they're in a bad mood. So anything that would make people deviate from their true score is what's considered measurement error. But what you're actually measuring is the observed score. So whatever score that you actually get when you ask them a question, that's your observed score. And it's a combination of people's true response plus this measurement error. So what you want to be able to do is minimize the measurement error such that your observed score, what you get when people tell you whatever they think, feel, or behave, is basically the same as their true score, how they truly think, feel, or behave. The more there's a discrepancy between your observed score and your true score, the more measurement error you have. And again, your goal is to minimize measurement error so that your true score and your observed score are the same. Now, granted, they're rarely ever exactly the same, but you want them to be as close as possible. So you want to minimize that measurement error. So more reliable measures have less measurement error than less reliable measures. So if you look at these two different outcomes, let's say these are students' scores on a test, right? Um, you have the distribution of 1 and the distribution of 2, right? The first one, the scores are very closely linked around 100. Whereas for the second distribution of scores, they're much more spread out, right? So what I want you to recognize is that the first distribution of scores has less measurement error than the second distribution, which is more spread out, which is what you want. You want to have less measurement error. And the less measurement error you have, the more reliable your measure is. Now, when we're trying to assess reliability, we typically use correlations. And we've briefly talked about correlations, so let's revisit it for a minute here just to make sure that we are all on the same page. Now, correlations look at the relationship between two variables. And specifically, it's looking at the direction and the strength of that relationship, right? And as we talked about before, a correlation can range from -1 to 1, with a correlation of 0 meaning that the two variables of interest are unrelated. A score of 1 would indicate that the two variables are positively correlated. A score of -1 would indicate that the two scores are perfectly negatively correlated. When you're looking at reliabilities of scores, you're going to want a reliability that's closer to that 1 range of this scale, not anywhere near either 0 or obviously not anywhere close to -1. So when we're talking about correlations, we're talking about correlation coefficients. Again, you want to have correlations that are close to that 1 range. So anything around a 0.7 correlation or higher is considered to be a reliable measure. And there are 3 different ways that we can test for reliability: test, retest reliability, internal consistency reliability, and inter-rater reliability. So the first type of reliability that we're going to discuss is test, retest reliability. And this is when you're looking at people's scores at one point in time and comparing it to their scores on the same measure at a later point in time. So let's say you give a bunch of people a standardized test today, and then you give them the exact same standardized test a week from today or a month from today. The idea being, if the measure is reliable, their scores today will be similar to their scores if they take a month from now or a week from now. If the scores are drastically different a month from now or a week from now, that would indicate that your test is not very reliable. You want to have similar scores at each point in time. So you're looking at the correlation between their scores at time 1 and their scores at time 2. One problem with test-retest reliability is practice effects. So because they've been exposed to the test at time 1, they may actually do better at time 2 than they would have if they hadn't been exposed to the test at time 1. So now their scores at time 1 aren't really an accurate indication of how they would do because it's been impacted by their exposure to the test at time 1. Our second type of reliability is called internal consistency reliability. So this type of reliability is when you give people a multi-items measure and then you give it to them all at one point in time, and instead of having them like take the test today and take it a week later, you give them all the items at the same time and you look at the correlation between their scores on each of the items. So maybe I have like 5 items looking at self-esteem, and we're going to look at the correlation between item 1 and item 2, item 1 and item 3, item 1 and item 4, and same with 2 and 3, 2 and 4, and so on. We're looking at the average correlation amongst all of those 5 items. So what we get when we try to calculate the average correlation between our items is what's called Cronbach's alpha. So this is the average correlation between all of your items. And Cronbach's alpha is a good way of testing for internal consistency. Our last way of looking at reliability or measuring reliability is inter-rater reliability. And this is when you have 2 or more judges and you're looking at the correlation of those judges' responses. This is typically used when you're doing behavioral research. You're observing people, right? So you might have judges observe how anxious someone is while they're giving a lecture, right? Or when they're interacting with a stranger. And they're going to be looking for different indicators of anxiety. So one judge might identify 5 different anxious type behaviors. Another judge might find 7 or 8, right? And the idea here is you want to see how closely correlated are your judge's ratings of anxiety. With the idea being that the more closely the judge's ratings are, the more reliable the measure is. So again, you're looking at the correlation between the different judges and their ratings on a particular thing that they're observing.